Hi everybody, this is Mr. Prue. I'm going to talk about the basics of coordinate geometry. And this starts with the basic building blocks of geometry, the point, line, and plane. But not that kind of plane, the two-dimensional surface plane. French mathematician René Descartes was credited as the first one to put two number lines on the plane, and we usually label those the x and y axis. It's always important to number the number lines so that we know what numbers we're counting by. And the two number lines meet at a right angle. We label where they cross the origin, which is 0, 0, and the two number lines cut the plane into four quadrants. We label those quadrants the first, second, third, and fourth quadrant. We need two numbers to place a point on the coordinate plane. Those two numbers together are called an ordered pair. And we always have the x value first in the ordered pair and the y value second in the ordered pair. So if I want to place the point A, 3, 2 on the coordinate plane, then you start at the origin and move 3 units to the right on the x-axis and 2 units up on the y-axis. Place the point, and that's point A. The point B is, again, starting at the origin and asking you to move 2 places to the left on the x-axis and then 1 place up on the y-axis. Point C, back 1 on the x, down 2 on the y, and you have your point. Point D, 4, -3 means move 4 places to the right on the x-axis, 3 units down, and put your point. Okay, I want you to pause the video here for a minute and try to practice writing the coordinates for each shape on this coordinate plane. So your job is to write the ordered pair for each shape, and I'll give you a second to try it. Okay, we're back, and the red triangle is in the first quadrant, and the ordered pair for the red triangle is 3, 4. The yellow square is in the second quadrant, and the ordered pair is -3, 2. The blue pentagon is in the third quadrant, and the ordered pair is -5, -2. And the green circle is in the fourth quadrant, and its ordered pair is 1, -5. Okay, equations for horizontal lines. So if we place some points on the coordinate plane, and we want to talk about the equation of the horizontal line that goes through the purple point. So there's this purple line that's going through that purple point, and all horizontal lines go through the y-axis. The equation for a horizontal line is y equal to whatever number it goes through on the y-axis. So the purple line goes through the point 2 on the y-axis, so the equation is y equals 2. The orange line goes through the point 1 on the y-axis, so its equation is y equals 1. The green line goes through -2 on the y-axis, and its equation is y equals -2. The blue line goes through -3 on the y-axis, and its equation is y equals -3. Likewise, equations for vertical lines will be x equal to whatever it goes through on the x-axis. So if I want the vertical line that goes through the orange point, the orange line's equation is x equal to -2. The green line has an equation of x equal to -1. The purple line has an equation of x equal to 3. And the blue line has an equation x equal to 4. Vertical lines are x equal whatever it goes through on the x-axis. Lines that are not horizontal or vertical have slopes that we can measure by counting the rise over the run between two clear points on the line. This line has a rise of 1 and a run of 5 between the 2 points on that line. So its slope is 1/5. Now, when we read a line in math, we read it just like we would read a line in English from left to right. So if the line is going up from left to right, it's going to have a positive slope. The slope of this line is 1/5. 1/5 is a positive number. So this line is going down from left to right, and therefore it should have a negative slope. So if we put 2 points on the line, we could measure the rise and the run between those 2 points. This one's going down 4 and over 6. So it has a slope of -4/6, but whenever you can, Try to reduce the fraction. -4/6 reduces to -2/3, and therefore the slope of this line is -2/3. If we're given a line and we're asked to find the equation for that line, we can use the slope-intercept form y equals mx plus b. M is the slope, and we can find the slope here by counting the rise up 2 and the run over 6. Remember, we want to reduce that to 1/3. And the second part of that is the y-intercept b. B is the point where the line crosses the y-axis. In this case, it's crossing at 2. And we fill both of these things in, so we have y equals 1/3 x plus 2. Let's try this again, finding the equation of the line connecting these 2 points. So we're going to use slope-intercept form, y equals mx plus b. The slope is down 6/4, which can be reduced to -3/2. The y-intercept in this case is 0. Fill in -3/2 for m, and the equation will be y equals -3/2 x. Please pause the video now to find the equation of the line between these 2 points. Okay, again, we're using slope-intercept form, y equals mx plus b, and the slope is up 3/4. The y-intercept is at 1, and we'll fill these in for m and b, and we get y equals 3/4 x plus 1. Please pause the video one more time to try to find the equation of the line through these 2 points. I'll give you a second to try it. Okay, in slope-intercept form, y equals mx plus b, the slope is down 3/1, and that can be simplified to just -3. The y-intercept is at -1, so we fill in -3 for m and -1 for b, and get y equals -3x minus 1. In this problem, we're asked to graph a line given the equation. So the best way to start here would be to look for the y-intercept. If there's nothing written in the b location, that means the y-intercept is 0. So we could start by putting a point at 0, and then place another point that is up 2/3 from the y-intercept. Now, once you have 2 points, that basically determines a line, so we just have to make the line go through those 2 points, and that is the line for the given equation. Okay, please pause the video for 1 minute and use a piece of scrap paper to try to draw a sketch of this equation on the coordinate plane. Okay, one more time, what you'd want to do is start with the y-intercept and place a point on the y-intercept, which in this case is 2. From that point, try to follow the slope, which is down 1/2. And then use a ruler and connect those 2 points with a straight line. So René Descartes' coordinate plane provides us with a tool that connects the basic building blocks from geometry to ideas in algebra and beyond. But remember, never put Descartes before der Horse.